Single period inventory model, Nikita Patel. Chase and Jacobs define inventory as the stock of any item or resource used in an organization. An inventory system is a set of policies and controls that monitor levels of inventory and determine what levels should be maintained, when stock should be replenished, and how large orders should be. Inventory control, also known as stock control, is a discipline which deals with the management of goods stored to satisfy a particular need or demand. Single period inventory. This model is also known as the newsboy problem, as it describes the problem of a newspaper vendor who must decide on how many papers to order per day, and any that are left over must still be paid for. This model assumes that the demand is stochastic. Single period inventory uses historical data to identify a variety of demand scenarios and determine a probability each of these scenarios will occur. When given a specific inventory policy, they can determine the profit associated with a particular scenario given a specific order quantity. It also able to order the quantity that maximize the average profit. Marginal analysis with discrete distributions. Finding inventory level with the lowest cost is not difficult when following the marginal analysis procedure. This procedure states that a business would stock an additional unit only if the expected marginal profit for the unit equates or exceeds the expected marginal loss. This relationship is expressed symbolically as follows: P equals probability that demand will be greater than or equal to a given supply. 1 minus P equals probability that demand will be less than supply. Marginal profit is the profit of selling the extra unit. Marginal loss is the loss of not selling the extra unit. Optimal order quantity. The optimal decision rule is to stock the additional unit if the probability times marginal profit is greater than or equal to 1 minus the probability times by the marginal loss. There are many ways in which we can determine the level of probability for which this relationship holds. Here are 4 examples of how it can be calculated. The main equation is that the probability is greater than or equal to the marginal loss divided by the marginal loss plus the marginal profit. The business would stock an additional unit as long as the probability of selling one more unit is greater than or equal to the marginal loss divided by the marginal loss plus the marginal profit. Marginal analysis with normal distribution. Marginal analysis with a normal distribution can be applied when products, demand, or sales follow a normal distribution, which is a common business situation. Firstly, 4 values need to be found. Number 1, the average or mean for the product. Number 2, the standard deviation of sales. Number 3, the marginal profit for the product. And number 4, the marginal loss for the product. The process of finding the best stocking policy is similar to marginal analysis with discrete distributions, which involves finding out the optimal stocking level. Steps of marginal analysis with the normal distribution. There are 3 steps. Number 1, determine the value of marginal loss divided by marginal loss plus marginal profit for the problem. Step 2, locate probability on the normal distribution table. This can be found at the appendix on the end of the presentation, and find the associated Z value. Step 3, finding the optimal stocking level using the Z value, which is the optimal stocking level minus the average or mean for the product divided by the standard deviation of sales. You must use the optimal stocking level equation, which is the average or mean for the product plus the Z value multiplied by the standard deviation of sales. The case study. Marks & Spencer is a business that uses inventory control. There is always a special case of how much to order, or should we order more stock at all. Marks & Spencer have a simple philosophy that if it sells, then restock it quickly and avoid stockouts. If it doesn't sell, get it off the shelves quickly and replace it with something which will sell. The Marks and Spencer's approach means putting a new line on the shelves of a pilot store and watching the customer's reactions very closely. Please continue reading the case study in order to find out more about how Marks and Spencer's and how they use inventory control. This will involve the electronic point of sale system, replenishment of stock, and how the sales floor is controlled. Benefits of inventory. There are many benefits you are able to get, some of which enable customers to be served conveniently and quickly, or the business would have to make everything as the customers request it. Another is that inventory can be used so that a company can buy it in bulk, which is usually cheaper. If there is an unexpected interruption in supply from outside the operation or within the operation, then inventory is an insurance. Inventory also allows operations to meet unexpected surges in demand. Different parts of the operation can be decoupled. Through inventory meaning, they can operate independently to suit their own constraints and convenience, while the stock of the items between them absorbs short-term differences between supply and demand. Limitations of inventory. Even though there are many benefits for inventory, there are also quite a few limits. Keeping inventory means the company has to fund the gap between paying for the stock to be produced and getting revenue in by selling it, which is very expensive. Large amounts of inventory around the business needs to be managed. They can be counted and looked after, which can get very confusing. Items can also deteriorate while they are being kept. Clearly, this is significant for the food industry, whose products have a limited life. It is also an issue for any other company because stock could be accidentally damaged while stored. Fashion constantly changes, and business rivals may introduce better products, leading to current products becoming obsolete while stored. Appendix A. This is the normal distribution table. You are able to compare a probability to a z-score, where z is the number of standard deviation from the mean. For example, if 0.4364 is a probability, the z-score would be 0.1.